Greetings, everyone. So let's go through a couple of examples of the process of completing the square as we were doing in class. So here's an example of a parabola written in standard form. Now, our goal with using completing the square is to rewrite this into vertex form or graphing form. And so the process is relatively straightforward, so let's go through it. The first thing we want to do is we want to recognize when we have a coefficient other than 1 in front of the x squared term. When there is a coefficient other than 1, like there is here with the 5, we're going to want to factor that out of the first two terms here, and then we'll start the process of completing the square. So when we factor out the 5, we're going to get y is equal to 5, and then I'm factoring that out, so 5 times x squared gives me 5x squared, and then I got to take that negative 40x and I'm going to divide by 5 to give me negative 8x. And then I'm going to leave some space for the process of completing the square because I've done the factoring. The 1 I'm not going to factor anything out of. I'm just going to move off to the side here outside the parentheses, which we'll deal with later. So now the next process the next part of the process for completing the square, actually to start the process of completing the square, what we're going to do is we're going to look at this middle coefficient here, the coefficient of x, and we're going to divide that by 2. So the first thing is divide by 2. And once we do that, then we're going to square the answer. Okay, so negative 8 divided by 2 is negative 4. And then negative 4 squared is 16. So then I'm going to add 16, and I'm going to subtract 16 inside the parentheses here. The purpose for this is I don't want to change the value of the expression. I just want to make it look different. And so by adding 16 and subtracting 16, I'm not changing the value of the expression. I'm just changing how it looks. Now, when you do this process, as we talked about in class, without going into too much detail, the first 3 terms here are always factorable nicely. They're called what we call a perfect square trinomial, and they always factor in a predictable way like we talked about in class. So let's go ahead and do that factoring then. So it becomes, x, and then that first step where we divided by 2, that is what is going to go after the x here. So negative 8 divided by 2 is going to be negative 4. So I'm going to put minus 4, and then I'm going to square that. And that's going to take care of the x squared, the minus 8x, and the plus 16. I haven't done anything with that minus 16 yet, so I'm going to put that there, and then I still have that plus 1 on the outside. Now from here, it's just a matter of simplifying the algebra for the rest of the problem. So we don't typically leave it in this form because this isn't graphing form yet. So I'm going to distribute the 5. I'm going to multiply the 5 times the first expression, which means it's going to end up on the outside of the parentheses there, and then I got to multiply the negative 16 times 5. I don't multiply the 1 by 5 because that's outside the parentheses. So I'm going to end up with y is equal to 5, and then I got my parentheses x minus 4 quantity squared. And then, so that's the first arrow that I drew. The second arrow, 5 times negative 16, well, that's negative 80, so I'll put minus 80. And then that plus 1 is still coming along for the ride. And then one final step, just to simplify the negative 80 plus 1. And so we're going to get a minus 79. And that is our answer to this problem. So we took our equation that we had over here in standard form, y equals 5x squared minus 40x plus 1, and now we've written it in graphing form. And although the negative 79 is a large number to go down if we had to plot this, we still could graph this relatively easily. We can identify the vertex as 4. Whoops, I'm using the wrong tool. The vertex is going to be 4, comma, negative 79. Remember, the x is the opposite, and the k is the h is the opposite, and the k is the same. So that's going to be the vertex. So if we're going to plot this, and it's got a stretch factor of 5, and it's concave upward, so positive orientation. So we can see all the stuff that we are supposed to see. So another example where we complete the square is when we want to rewrite a circle from standard form into its graphing form. And so here's an example. This is the equation of a circle in standard form, and we're going to rewrite this into graphing form using completing the process of completing the square. Now notice the variables are not gathered together by the type that they are. Like the x squared and the 8x are not next to each other. So I'm going to rearrange the order. And since I'm keeping everything on the same side of the equal sign, I don't have to change signs or anything like that. So I get, just as a rewrite, x squared plus 8x, and then I'm going to leave a little bit of space, plus y squared minus 10y, and then leave some space, and that equals negative 32. In this way, now I've got the x terms together, got the y terms together, and then I could start this process here. I don't like the way that line looks, so let me change that really quick. So the nice thing about this example is there's no coefficients other than 1 on the x squared and the y squared, so I don't have to do any factoring first. So I'm having a little trouble with my screen here. Hold on. Okay, so when I work this out, I'm going to do the same process that we just talked about. So since I don't have to factor anything here, I'm going to take this 8 and I'm going to divide it by 2 to get 4. And then I'm going to square that to get 16 again. And I'm going to put a plus 16 and a minus 16. Squeeze it right in there. I'm going to do something similar for this negative 10. Half of negative 10 is negative 5. Negative 5 squared is 25. So I'm going to do plus 25 and minus 25. Right there, and I had to squeeze it in because there's not a lot of space, but I think you guys can follow. So again, I'm going to take the first 3 terms here and then the first 3 terms for the y's, and I'm going to factor them. And they're going to factor in the same way that the other examples factored. I'm going to use x, and then I'm going to take half of that 8, which is plus 4, and then I'm going to square that. I still got this minus 16 roaming around here that I've got to deal with in a moment. But let's do the other factoring here. So y, half of negative 10 is negative 5. So y minus 5. Don't forget to square that expression. And then minus 25 equals negative 32. And at this point here, now you just got to do a little basic algebra. And I'm going to add 16 to both sides. And then I'm going to add 25 to both sides. And then I'm going to be left with, well, the answer to the question here. So I'm going to have x plus 4 squared plus the quantity y minus 5 squared equals, and then negative 32 plus 16 is going to be a negative 16, and then negative 16 and 9 is 25. I'm sorry. Negative 16 and 25 is 9. Excuse me, I commuted it in my head. But just add together. If you're confused where I got the 9 because of my misspeak right there, just add these 3 numbers together and you'll get 9. And then we got the answer to the question right there. There's the circle in graphing form. And from that, we could see quickly that the center of the circle is at negative 4, positive 5, since both of these values are in parentheses here, we use the opposite. And then the radius is the square root of the 9 right here, which is 3, because 3 times 3 gives you 9. So go practice that technique and make sure you're ready to handle it on any quizzes or tests.